you're welcome to our class. I believe you have R installed. You have the current version installed, don't you?
No, mine is still showing. This was not the computer I used last time. So it's showing 3.5, but I can use this and update later.
Okay. Do you know how to do the updates?
I'll pull the video from the very first class.
Okay. Maybe when we're doing the exercise, if we have time, we can do that installation. Okay. Some of you are not completely new to R, so let me ask the question: what is R? What do you know that? When you think of R, what do you? Someone asks you, someone from Kapancha and come and ask you, what is R itself? What would you tell them that R is?
Data processing and analyzing tool.
Data processing and analytical tool. Okay. Do we have any other response?
I think it's also it's majorly an open software, an open source software.
Open source software. Okay. Alright. Okay. Okay. You're correct. Open source software that does what? You're correct, but there's so many open source software.
And that's basically, like she said, gives the data analysis.
Okay.
And it's, from the little I've seen, it involves writing of programs to achieve different tasks as thoughts of.
Okay. Okay. Alright. It's fine. Now, from the R documentation, the manual called An Introduction to R, we have, this is an abridged version of what was there, or what is there. And you can see that it is an effective data handling and storage facility. Very effective. It's also a suite of operators for calculations on arrays. And we know that majorly data that is subject to analysis always comes in some kind of array. And when we say array is a collection of data that is organized in a particular way. Okay? And when I say data now, we are talking about points of data. The actual word data, or from the word datum. So it has a suite of operators that will enable you to make calculations on those arrays, those collections of data. It's a large collection of tools for data analysis. So it's not just a tool, it's a collection of tools. It's not only a large collection, but it's a growing collection. It keeps growing. And I can say both from usage, experience and observation that when you're using R, you can easily operate at the cutting edge of data analytic knowledge. Okay? So it also has graphical facilities for data analysis and display. R is very powerful. data visualization. Very, very powerful. Well, it's powerful because unlike so many tools that you find, like if you've done any kind of analysis or try to do any kind of or view any kind of stats, maybe on websites and all that, or even social media, you can easily look at the analytics. They'll show you graphs and all that, but you can't manipulate those things. You cannot fine-tune them. This is over you. Okay. You cannot fine-tune them. But R is such that it gives you fine control over your graphics. Very fine control. You can customize graphs very, very easily. Okay? That's why R is very useful for data visualization. Advanced data visualization. Okay, it is also a well-developed, simple and effective programming language. So R itself is a programming language. So in a nutshell, you will see where it's written. R is a programming language and an environment for data analysis of statistical computing, something like that. So it's a language and an environment, and by environment it means a whole microcosm, or I wouldn't call it a macrocosm. It's a universe of so many things that are interconnected and interrelated. Like you were asking me, did I make these slides using R? Yes. Okay. All right. We've installed. Let's skip this slide. Now working with R. Some of you have already worked with R before, but now let us look at the nitty-gritty. Essentially, there are two ways of working with R. You can do so interactively, and you can do it non-interactively. When you are working interactively, what you are doing is you, the user, the operator, you are providing inputs into R, and R carries out a computation and then returns, something to you. It does. So your input is like a command or a request to R, and then you get R to do what it wants to do. So that is interactive. The non-interactive approach, where R commands, R instructions are written in a file, in a text file. And that text file is called an R script. That file can now be supplied to R, given to R, and R will now carry out those instructions. Okay? So usually when we are doing, maybe you're just doing data analysis, or you're just doing some checks, you're experimenting, you need to do that in an interactive session. Now, the knowledge you've gained, or the stuff you've done interactively, you can actually store it in that script file. You can save it in that script file, and you can write your script in such a way that you don't need to interact personally with the computer to get R to do what it wants to do. That's why it's said to be a programming language. If you remember the last point in the last slide. A programming language has certain elements. You can store data in variables. It has logic, okay, and all that. So those elements allow you to write a program, as it were. And that program can run, you can automate a lot of what you are doing with that. So you don't need to sit at the computer. You can write a script, and that script runs for you, does the analysis for you, does so many things for you, okay? And then the computer does all the hard work for you. So that is the value of scripting. So as we go through these trainings, actually, scripting is not really emphasized upon in many situations or many interactions with R, because generally people tend to work with R interactively. But it's important for you to understand scripting as well, because it will make your life much easier. There are tasks you don't need to sit at the computer to do. If you know how to script very well, write good scripts that you do so many things. The errors, they'll check the errors for you. They'll, without the program stopping on its own, to just check the errors for you, run it, send it back to you, for you to deal with later, things like that. So that if you know how to write good, write a good flow in the program, you can write good scripts that will make your life much easier, especially when you have repetitive tasks. I'll give you an example. Just yesterday you had a program, and now you've decided that this program is going to hold every quarter. So much of the analysis that you are going to do now, it's better for you to start planning to write scripts around those things, around those tasks. So that down the line, as you are repeating those projects or those activities, instead of having to sit down to do the same thing over and over again in a script, the more you repeat the activity, the more you can fine-tune your script and make your life much easier for you. Okay? And the scripting is also what enables our functions, to be shared. So I write a function, I can share it with you. You use this to do your work, something that I did. Scripting allows you to do that, and the extensions that we have that we call packages are all based on our scripts that people have written. Indeed, R itself is based on scripts that have been written before. Okay, I will explain more as we go down the line in this training. Now there's a term here that we have on this slide: read, evaluate, print, loop. I just want to explain that quickly before we jump over. The read, evaluate, print loop is a kind of system in programming where the user provides input into maybe a console. The program reads that input and then evaluates it and prints out something. That is called the output. Especially generally speaking. Sometimes you don't really get an output. It just gives you some other side effect. But this is just the basic way that it works. Okay. So it's not only R that does things like this. We have other situations like example is the JavaScript, where you can in your browser you can type in some JavaScript code and it will give you the output there and then in your browser. So the R console, I don't need to talk much about this. You guys know this already, I believe. The console is just an application. A computer it looks like a window, and that's where you can put in your R code. The input is supplied at the R prompt. The R prompt by default is the right angle bracket. So basic R syntax. In computers, data is stored in memory. What we mean by this is that when you provide an input, maybe from the keyboard or from the mouse, you are sending data. Data is sent into the computer's memory. And by memory, we're talking about the RAM. And then the processor takes that data and the accompanying instructions and does some work with it. Now in R, data in memory, they are commonly referred to as objects. And the objects are organized into a variety of data structures. Okay? So there's the way they are organized. They are organized to, for it to become somehow meaningful and useful to you. Do you have a problem there? It's not working?
Sorry, I'm distracted. Sorry.
Are you okay?
Yes.
Alright. For instance, our objects can be one-dimensional. So what we have there is an R object that contains characters A, B, C to F. Now, there's another one down here that has the same data, A, B, C to F, but it looks different from this one. The difference between these two is their dimensionality. This one is a unidimensional object, and this one is a multi-dimensional object. So R has taken the data and organized it depending on the way you have given it instructions to use or handle the data. Alright? I didn't show you the code I used to write to create these two objects. But the code is different for the two of them. Right? So this one is data just in a row, a single dimension. The other one is two dimensions. In R, you can have even more than two dimensions. You can have 3, 4, 5, 6. You can have so many dimensions. All right. Okay. Then data types. This is something that we'll go into more detail. But just know that data in the computer, like I said, in memory, is just bits and bytes. I don't know whether I will ever have time to talk to you about this. I think Nena is a computer major, so maybe one day she will teach us about bits and bytes. Okay. So the bits and bytes is all that is about, but that's only the machine can understand bits and bytes. Human beings need it to be interpreted. And that's why we have the data types in computing. In programming particularly, we have data types. Okay? And essentially we have 3 types here. We have strings, numbers, and booleans. Okay? This is just an oversimplification. Strings are characters. And by characters I mean your English alphabet, and your punctuations, even numbers can be as characters. Okay, you can have a number that is just a character. Then we have numbers or numerical data, which we use for computations. You don't use strings for computations, you use them for other things. But you use numbers for computation. Then we have booleans. Booleans are for logic, usually. So we have true and false as the as booleans. Okay. So there are others, but these are the ones that usually come from a user. These are the ones that can be supplied by a user. There are other types that we will go into later. Then constants. Okay, constants are just when you provide a literal constant, like a number or a string, R just brings it back to you as an unevaluated output. Okay, this looks like why am I talking about constants? It looks like something that doesn't make any there's no value, but when you come to start programming properly, you know the value of constants. Okay. So booleans, of course, if you just apply boolean true and false, is also going to be a constant. It will just return it to you. Note that in R, when you say true or false, for it to be a boolean, it must be in all uppercase. Okay. And then variables is simply when we assign a name to a block of memory. When we give a block of memory a name, is a variable. And the reason why we do that is because we want to make it easy when we're programming. We want to be able to easily use that block of memory repeatedly. Okay? And know what is there, and know what will be put there. It makes our code expressive. And in R, note that the variable names are case sensitive. So if you have 3 variables, let's say in your program, these 3 here, var, and var, even though they all sound alike, they are different names. Okay. Then variable naming rules. Are you guys familiar with this already? Variable naming rules. There are rules for naming variables in R. You cannot, a name cannot start with a special character except a dot. In fact, R names generally cannot contain special characters. By special characters we mean like punctuations. Full stop, comma, ampersand, dash, underscore, star, question mark. Those are all special characters.
Why is it not a special?
No, in every programming language there are always rules for naming. There are always rules for naming. Okay, so the only special characters that you can use in an R variable are the dot and the underscore. So you can't have a name that has dash. A dash, for instance. Okay? But at the beginning of the name, you can only start out of these 2 that are allowed, only the dot can be used at the beginning of the name. Alright? And then you cannot start with a number. If the name can contain a number, but you can't start with a number. It must be either at the within the anywhere else but at the beginning. And then you can use uppercase, small case, camel case, snake case, any case you want. They are all allowed. Okay? But it's advisable when coding. This is very important because why this thing I'm saying now is like why am I wasting time on all these things? These are very important things that you must learn to practice when you're writing code. For example, in any code you're writing, even if for yourself, try to be consistent. If you're using uppercase, for example, for all your variable names, let them be uppercase. Or even if there's a reason why they'll be different, you should know the reason why you're different. And if you're in a corporate setting, like now you're in a big office and everyone is using, many people are writing writing R code, or any code for that. That company will have a policy or a style guide. Do you get me? they will have like a style guide. This is how you should write your code. So that if someone comes to maybe maintain your code in your absence, already there are rules in the company for that. So maybe down the line, let's say, just assume you have a big team of people working with you in the future. They should be able to. You should know that this is not something that you have to put in place for good quality. Then use meaningful names. Now look at these examples there. Okay, the first one, you have a variable called x. That arrow operator assigns. This is what we use to create the variable. This one here. Okay. So this is allowed, but it's not the best, because this x doesn't really mean anything. Like when you use this now, this is good because this, you know that this is a string. At least you know that it's a string. Now this one is not allowed. I told you that you can't start with a number, you can't start with the underscore. Okay? Now this kind of thing, now as I'm showing you these things, as I'm speaking to the slide, if you have R open, what you do is you try it out on your own. This in the practice, when you start seeing the errors, it helps you to remember. Okay, let me ask the question now. What is the difference between a string and a name from what we have done so far? You guys were looking all bored as if you know it already.
I don't know if there's really a difference. The string is the same character now. It's characters.
Yes, they both use characters, yes.
Yes, but then maybe the name is the one that has been assigned to the variable that has been assigned.
Okay, yes. If you are creating a variable, you use a name. You as they say, it's technically correctly said that the name is bound to the object, to the string. Fine. It's not really the difference.
Yeah.
Okay. If I write a name, I write a string side by side, how would you tell the difference between the two?
Because if I'm correct though, the string from what you said, so you said the string makes up the object itself.
It's an object, yes, I agree.
Yes.
Objects.
One can identify that as an object, but the name, like you said, defines a variable.
You are right.
So it's more or less creates like a block of the memory.
Should I say the last slide we said now, where the name cannot start with a dot, the difference, right? You cannot start with a dot, you cannot start with you can start with a dot, but you can't start with an underscore or a number.
Yes.
And I don't know if you said the string can do that.
A string can contain any character, any character imaginable.
But the name cannot.
But
that's not the difference.
That's not the difference. Because okay, let me assume.
Yeah.
I have a string. I have a name called Boy.
Okay.
And I have a string also called Boy. Now, how would you know that one is a name and one is a string?
Could it be by the way it's highlighted?
The inverted, is it the inverted commas?
It's not inverted commas. They are called quotation marks.
The quotation marks.
Yes. That's the difference. If you noticed, the string always has, they have quotes, either single or double quotes, bounding it from the beginning to the end of it.
Yeah.
And in fact, that is how R knows that this is a string. That's those quotes that you put there is you telling this thing I'm writing here is a string. Okay, so back to what I was saying about constants. If you remember, you know constants. If you, like I said, as I'm talking, be experimenting in your R console. If you just write in your R console, write boy, just boy, without with the quotes, and then write boy again with quotes. You see that the first one of them is a constant, and the other one will give you an error. And the error message will tell you something. Okay.
Error object boy not found.
Yes.
Without quote. Go with quote.
Object boy not found. Because you have not made any object called boy in that session, in that particular session. But when you put a string,
It says one boy.
boy. So it just gives you boy as an output. So that is a constant. Clear? Okay, good.
So when you make use of a string, you are defining a constant. Is that what you're saying, sir?
No. Well, let me just put it to you this way. The string that you wrote, supplied to R,
Yes.
is called a literal string. It's a constant. It doesn't change. Do you get me? That's why it is a constant. It doesn't change. Now comments. Quickly. When you're programming in R, if you write in your code a hashtag or pound sign, some people call it pound sign. Anything beyond that pound sign is a comment and will be ignored by R. It will not be executed. Okay? In this code here, you see that this whole thing here is comments. Now, in this particular line, we have code that is being executed. But to the right of it, you have a comment. Now, why this happens is because R reads code or a script from top to bottom, and then from left to right. So in this particular line, R started reading from left to right, and then encounters the comments. So it just ignores this one. So you see that only this pi was evaluated. This pi happens to be an inbuilt constant inside R, okay, which is the mathematical constant pi. Okay. Now operators. Remember, we said that R it has a large collection of operators. Remember, it has operators that are used for calculating on arrays. So these are the operators. I will not waste time on these ones, on most of them, because we know these ones are very familiar to us. Addition, subtraction, multiplication, division. Now these two here, integral division and modulo. Does anybody know what integral division is? Okay, does anyone know what addition is? Okay, sorry.
I'm trying to remember.
Okay, does anyone know what modulo is? Okay. Now, what integral division is division. You divide and ignore any remainder, any remnants of the division. Okay? So that means if you have a division that will give you some decimal, right? Some decimal points. some decimal values. You will ignore all the decimal values and just take only the integer. If you remember in your mathematics, you have integer and what is the other place we call it? I've forgotten. Okay. So you drop the what is there now?
The remainder.
The remainder. So the modulo is the reverse.
Take the remainder.
You take the remainder. So there are many times when you're computing, you need to do this, to do something like that. You need to just calculate them. So these operators will give you, this is a percent /%. That's integer division. Then double percent is the modulo operator. Okay? We have an example here. So we have two variables. One is A, the other is B. A is 32 and B is 12. So A plus B is 44. A minus B is 20. A times B is 384. And then A divided by B is 2.666. So notice that R has tried to do some rounding here. So this is 0.6 to infinity. So in my own settings, R has been told to round this thing to the 10 to the power minus 6. Okay? That's to the 6th decimal point. Now A modulo B will give us 8. Okay? And then A integer division of B will give us 2. Can I proceed? We have comparison operators. Less than or equals, greater than or equals, equals, and not equals. They're not equal. Okay? Now this one can cause confusion because in math we are usually used to a single equal sign to mean equals. In computing, it doesn't mean that. In most computing languages, including R, when you see an equal, only one of them, it is an assignment operator. It's used to assign. So in R, actually,
one equal
is assignment. Yeah. So even where we use the arrow, that arrow operator, you can just use an equal sign to have the same effect. But in R, we have reasons for using the assignment operator, which I don't want to go into right now. Okay, it is better to use that one. Later, I will post. There was a tweet I did on this arrow operator. I'll post it on the Slack channel so you guys can read it. Why you should use it? Why you should use that one? Not use equals to assign.
But it's not like if you use the equal sign to cause a major issue.
It don't cause, many people just use it, but there's a strong reason for not using it. Okay, it's some advanced stuff, but I'll share the link with you. You can read later. Then not equals is exclamation equals. Okay. So you can find these examples here. A is the same, A is 32 and the B is 12, the same thing, okay? So when you say A is less than B, R tells you it's false. A is less than or equal to B, R tells you it's false. Okay? And conversely, A is A is greater than B evaluates to true. And A is greater than or equals to B also evaluates to true. Now, is A equal to B? R evaluates it as false. Is A not equal to B? Says it's true. Okay? And these are very useful operators which you use a lot when doing your computations. Okay? Now, functions. We have a quote from John Chambers. John Chambers is the inventor, creator of S. S was a language that was used to create R. He said to understand computations in R, two slogans are helpful. Everything that exists is an object, and everything that happens is a function call. So anything you want to do in R, you want to use functions to do it. Even to quit R, is a function that's used to quit R. For example, if you want to close R, I said already, you need to use a function, and that's the function Q. If you type Q with open and close parentheses and hit enter, you'll be prompted to save workspace instead of closing R. If you want to check your R version, for example, you need this function, get R version. It will just show you your version. So there are tons and tons of functions. So we don't memorize them. Don't even try it. There are some you will remember as you use R. But don't never bother yourself trying to memorize them. You're wasting your time. So there's a function called help that helps you to know more about the function. Okay? And Google is also there to help you. There are sites like Stack Overflow, which you must join.
Stack Overflow.
Yes. It's best for you to join that site because when you run into problems like we all do, you can always run there and ask a question. And there are many people who are eager to answer questions there. Okay? Or you will even find that someone has already had that problem. Now, R functions, how you know a function in R is that it has a name and you see double parentheses. That's how you know a function. And you may or may not have arguments within that are bounded by those two parentheses. Okay? We have already talked about operators. Actually, they are functions. But I will not go into that now. This is advanced stuff. If you continue on this journey with me far down the road, you get to know about this as well. Okay? Now, R documentation. This is very, 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 very key. The good thing about this is that your R inspection comes with documentation. You don't even need to go online to check so many things. It comes with it. It's very handy. The main R manuals are there. If you type help.start, you'll be taken to a page where you find the main manuals, like the one I quoted at the beginning, and introduction to R. There are other ones, that are also there. Okay, so for those that want to go into programming, really program. Now let me make a comment here about R. There are two kinds of R users, by my assessment. We have the R user, just the user. The R user doesn't need to know much about programming, and that's really the beauty of R. It has a very simple entry point. Within 2 hours, you can learn how to use R to do your work. Really. Why I'm even taking time to teach you to someone, I'm going slowly because I'm assuming that some of you will want to really go deep into it. Otherwise, if you want to just do quick analysis of some data, maybe draw a quick plot, nothing to elaborate. You're not doing any machine learning and all that stuff. 2 hours is enough to teach you about R. Really, you can learn enough to take off and pick up a few other things on the way. Right? But the other category of R user is what we have the R developers. Now, an R developer is someone who writes scripts, writes packages for other people to use. And those other people, they don't have to be a worldwide audience. It can be within your office. Or let's say you're running a project. What project are you handling now? What are you handling now? What are you doing now? Your current project.
School or work?
No, current, whether school or work.
Implementation plan. I'm sending out implementation plans for strategic.
Okay, good. Now, you can actually use R to help you do that, carry out that assignment. And then, if you are an R developer, you can now create a package around that project that your team will use. And if it's something that is so lacking, I know you are a PhD student, right? Okay, now you can write the package for your PhD project, because ultimately your research is going to go out, and that your PhD, you can write something in your PhD that would be useful to other scientists, and design an app package around it. Do you get me? So you can just be a user, want to just draw a chart, and just release it. That's an R user. An R developer programs, goes deeper, and does a lot more.
So I can just draw a chart from the surface.
Yeah, you just get the data and then draw a chart and then get out and go your way. You print it and you just save it and as a picture and go your way. I use R live sometimes. Depends on the situation or the drive or whatever it is or the idea I have. Right? The other day, what did we do the other day? Just 2 days ago, because we had a program, we wanted to get some data. People that had registered online, we wanted to have their names to print it out. I wrote about 10, 12 lines of code. We did it. We got the data PM. We stripped it down. We moved all the unnecessary data. The one we wanted. We created a fresh CSV file, and then. Right? And then you did a printout. Let me tell you, I could have gone further, even do the printout from R. You get so that's just a simple thing that we just did. Right? Now R help is the other one. That one is for regular day-to-day coding, because you always need help. Even functions that I've used over and over again, I always cross-check them, because there may be some details that I may need to apply. Yes, you have something you want to say. Okay. So there are 2 ways of using help. Because you can use the word help, that's the name help, parentheses, put in the name of the function or topic you want to study, or just type the question mark in front of the name and it will open help for you. Okay, so that's something you can always try at any time. Now we are now coming to the meat of the matter. Important data. There are so many approaches, and by my plan actually was today I would have gone into different ways of importing data. But for today, we're going to use CSV file. You guys know what CSV files are already, so I don't need to explain to you what the CSV file is. Okay, to import data from a CSV file. Yeah, we use this function, read.csv. Read.csv will just read that CSV file, and it will create a data frame. Now, a data frame is just a table where you have rows and columns. So, for example, if you have a file called myfile.csv, this is, and then we want to create a data frame called myData. This is the code we use to do it. As simple as that. Now, the point I want you to note, this argument that we are supplied here, this string, is a path. It's a path. So the way we are writing this function, the way we are writing this code, we are saying that this file is in the same directory as the one in which we are working in right now. I've not gotten to the issue of working directories in R, but whenever you're working in the console, at every point in time you are working in a particular directory or folder. Okay. So the way I've written this thing, this function, the assumption here is that for it to work, this my file must be in the same folder wherever the R prompt is, wherever we are working in at that point in time, the current working directory. That's why this thing would work. Okay. So the argument here is a path. It's not just the file name, it's the path. So if it were in, let's say, a different folder, we will need to give the path, the correct path, either full path as absolute path or relative path. Do you know what we mean by these two terms, absolute path and relative path? I will explain to you later when we go into some of the practical aspects of working. Okay, but just know that when you are trying to work with a file, notice this: the file is in the file tree, in the file system. It's in the file system. So for you to access that file, you must get the path. Just like when you want to browse a website, you have to give the correct URL. That is also is a path. Do you get me? Now, having imported the data, we now need to exploit. Now this is a real life example that I've created. We have a CSV file called emptycars.csv, and we have used read.csv to read it. And this is our data frame called that. Okay. Now the function ls, what this ls does is it lists out what we have in our workspace. All these functions, all these things here, A, B, C, D, CSV, DAT. Now these are things that were created while we were doing this presentation. And the one that we have now is this DAT. Now, what we're doing now is we're exploring data. What is key here for you to understand? Many people are used to graphical user interfaces. When you're working with the console, the only thing you have is a prompt. Just like when you're working in a command prompt, or you're working in PowerShell or any of those things, the only thing you have at any given time is that prompt. Do you get me? And in R, for instance, R gives you only the prompt. They don't give you anything else. A programs like a shell, like the shell. Normally, they have a prompt, but they will also show you the path to show you the folder where you are in front of the prompt. This making sense, please? Okay. So if you have imported data, you now need to explore it. So you have to start knowing what are these data made up of. So that's what we call exploration. So there are functions that we use to do that. First of all, we want to even know whether the data even exists in the first place. So LS will list it for you, or you can use this function exists that you will check whether it is there or not. So it's there. This function called DIM will check the dimensions. The return value of this function is always a vector of two numbers. And the first one is the number of rows, the second one is the number of columns. Okay? Then if you use this one, view.dat, okay, I was going to give you guys this thing. But, I didn't do it.
So this, the LX here,
Yes.
okay, is it based on what you have, the output you have before? Like when I use the LX,
You will not have what I have.
it just showed me A, B.
Because you have the one space.
Yeah.
Exactly. So why this is so here is because these slides are built, okay, using R, and then all the objects created in the sample code, they exist in that session. That's why it is displaying them. So all these code samples, they are real code executions, done when I built the slides right here. Do you get me? Okay. How much time do we have? Okay, we have some time. We're almost there. The function called call names or names will give us the names of the columns of that data frame. The function called str will give us what is called the structure. And the main thing you will see in the structure, let me just try and point at them. This function, it will return the type of object. Or let me say kind, I won't say type, let me say kind of object. So this is a data frame. And it has 32 observations and it has 12 variables, as you saw earlier. Now, these dollar signs indicate each of the columns. So this one is X. It's called and it shows us the type. The type is a factor. I'll explain to you later what the factor is. This one is MPG, and this num is numerical. You can see the first few values. This CYL is an integer. You can see the values here, and all that. Okay. All right. That's what SCR does. That's some analysis. We can quickly do some exploratory spelling analysis of the data. Note: the approach will always differ for any given data set. So the approach we have used here is just binding that you must use the same approach. We have a function called summary that will give you a summary of the individual variables. Okay. So you see X here, it's giving us a summary. gave us the first few values, then gave us the total number. This MPG, because it's numerical, it normally gives you the minimum value, the first quartile value, the median, the mean, the third quartile, and the max as maximum. These are all statistics. Okay, so it's similar for all the rest of them. The rest are all numerical and integers. So you have it there. You can use the dollar sign operator to extract a column. So if you say that dollar sign MPG, it will extract only that column. So if the MPG column, we have a column here called MPG. If you use this dollar sign operator, it will just extract it. This is called subsetting. So I'm not going to go into this just to show you that it exists and it's very useful for analysis. Now, to make a variable, you can use this to make a variable, another variable entirely. So we're going to check our workspace to see what's there again. You have seen what is here, right? How many items do we have here? We have 1, 2, 3, 4, 5, 6, 7 items. Okay. Now we're going to create a variable called call1, and we're going to assign whatever is in that $MPG, that same column. Okay. Now when we run it, notice that there's no output. Like I told you, this is a code that is being run. There's no output in this instance. And then the reason why there's no output is because we have assigned it. When you're creating variables, there's no output automatically. Okay? Because we're not saying, remember what I told you about constants. When we send this thing out like this into R, it is like you're saying that like you're putting in a constant. Are you following?
Yes.
Okay. So look at this now. We see that we have an extra object here called call1 has been created by this code here. Now if you want to now view the data, if you run this call1, you see that this thing shows. Now there are other exploratory functions we can use. For example, now we can say the sum of call1. This function will just give you the sum to add everything. You see how convenient it is. So assuming you have maybe 1 million numbers. All you need to just put it into a variable and add it up like this. Range. The range will give you the lowest number and the highest number. So you have them here. The minimum, of course, this function will give you this one, and the maximum, this one. Okay? So there are times when you want to just know what is the maximum of this one. Just to run this function, it gives it to you. The mean, the median, the standard deviation. This function called 5num. This is a statistical. It's called Tukey's five numbers.
The first 5 numbers.
No, these 5 numbers are these numbers are. If you run this thing now, if you run this code, question mark 5num, you will see what it means. I won't talk about it. Check it by yourself. Now you can plot call1. You want to do it by yourself.
I remember that you have the data.
Yes, I'm sorry. I forgot to send you the CSV. I would have sent it to you.
It just gave me like an HTML file.
That is the help file for that function. So anytime you want to check what does this function do, you just type question mark the name to open an HTML file for you to read.
So from what I'm saying, it says it works on the minimum, lower range, median, upper range, and maximum.
That's it. Now we have exercise, I'm going to do it. I'm doing it. It's for you to watch. It's for you to watch me do it and to learn. We're going to do a practical analysis session. Now we're going to download data from this site. Do you want to do it with me? You do it at home, huh? Okay. So let me just do it. You want to try it? Good.
I don't have network at home, so let me
No,
just
fine.
try it.
Okay, you have it. You have the right one.
Yes.
So let me just copy the link. Put it here for you. So I'll just click here and open the thing.
Is it out that is opening it?
I'm opening this one in yes, it's opening in our studio. Doesn't need to, I don't know why it's opening there. But it's not opening there, it's opening in the browser. Download this data. And then do that size. Please, if you have any question, ask me immediately. I mean, documents.
Sorry, so have you downloaded it?
Not yet. But you can go ahead and download, but I'm looking for where I'll put it. I'm looking for where I'll put it. I'm going to check. Let me just change the directory to something like that. there now. Download. They will ask you. They will ask you to log into this site to sign up. If you haven't done sign up, but this is a Kaggle. Kaggle is a site for data scientists for doing a lot of things. So I'm saving it in a folder called exercise, right? Notice that it is a zip file. You know what zip files are? Okay. Has it come yet? It's coming. I think it's done. So there's a function to check the content of a directory. List files. List files will list, so it is there.
Why did you just list that one?
You mean LS?
No, why did you list that? Okay, just from...
I saved it into
that.
yes. I made a folder called exercise of FIFA, and then I entered into it, and then I now checked whether the thing is there, and it is there. So this is, see now, the working directory is the same directory where this file is. Okay? You check your working directory by using getwd. Yeah, I spelled it. Getwd. Okay? Now, we want to import whatever it is. Now from this, by reading this page, I know that this thing is a CSV file. Okay, otherwise, I'll have to start doing some other stuff, but I know that this is what is there. This is the file that is inside that zip file. So I'll just extract it. And the function for extracting zip files is called unzip. That's in R. Okay? So if I say unzip, exercise, no, sorry. What's that file name? FIFA 19.zip. Okay?
Is that quotation mark? Is that quotation mark?
Which one? This one?
Yes.
Yes, because it's a string. If you check the help file for unzip, you check the help file for unzip. Why I'm using a string? Because you need to know, you will know from the documentation. Now I'm doing this because I already checked it before. I learned about this function before, so I now know how to use it. So when you don't know, you need to check to know how to use it. During the next class, I will teach you clearly how best to use the help file. Okay, but if you also got this in here, this argument says zip file. The path name of the zip file. Okay, so that's the argument that I just used, the first argument here. Okay, that's what I did. And the value, what it gives you as the result of using the function. Okay, I'll not go further than that. But if I now check the folder again, what is in the folder? We now have two files there. Data.csv and FIFA 19.zip. Okay. Now we have extracted what was there. Usually, after extracting your zip file, normally we like to delete it immediately. So we don't create confusion. So file remove FIFA. Did you did you observe that my this thing is going fast when I'm typing? Now when you type the first few letters of anything like this, if you want to, if you use tab complete, it just complete it for you if it's there. And it's also a way of avoiding typographical errors. So now if you check again list files, you see that it's only data.csv that is there. Now we want to import this into our session. Let's look at our slide again, the slide. It said unzip the file into the same folder and import into R with the name FIFA.
But when I downloaded it, it went straight up to downloads. Do I have to create it?
No, it's because of your settings.
No, as in when I downloaded it from the browser.
Yeah, it's because of the way you set your own browser.
Yes.
Mine, I said this that always ask where to save it.
Okay.
But you set yours always save in downloads. So what you can do is you can move it from downloads to another place to now work with it. Yes. So now import into R with the name FIFA. So let's now do it. So the name FIFA is what we are giving it. And import into R using the arrow operator. By the way, I'll post that one in the group, in the chat later. Post in the chat. So we said the function we will use is read.csv, and our file is what? Data.csv, and then we do that, and then if we now check our workspace, we now have FIFA there. We have created an model called FIFA. Check if there is a variable called FIFA. Check if check if a variable called FIFA exists in our session, which we have done already. Check the data type of FIFA. What is it? So to check the data type, there's a function called type of. So we just check type of and use FIFA. Yes, because that is what the function requires. Besides, it's an object that we're dealing with here. But like I said, there are some functions that will tell you make it sense. Let it be as a character. For example, exists. If I say exists FIFA, I know this from experience, it will say something is wrong. But if I change this one to quoted version, it now works. It has been true. So each function has its requirements. You get me? So type of is list. Type is list. I'll tell you more about lists, okay? Later. But we know that I'll tell you about this later. Alright. So the next, I think there's something more. Now check the dimensions of FIFA. How will I do it?
Yes,
I think it was defined that FIFA as
structure STR.
STR will give us STR will give us the dimension. Yes, you're correct. STR will give us the dimensions. So STR will give us more a lot of things, right?
Yes.
But
The dimension will give us the column.
Okay, let me ask them. I'll get you.
I just defined it as column before.
No worry, we'll get there. Now, STR FIFA will give us this. Let's extend this a bit. It's a lot, actually, because we have. See, so these are the dimensions here. Data frame, 18,207 observations. It's 9 variables. Okay. Now notice something when you're working in R. You see this dollar sign here. Whenever you have this kind of thing in your output, it means there's something else that is not attached. It goes beyond this place, so you can't see it. If you want to see it, you need to extend the window a bit. It should show you more to the end of the breakdowns. Okay. All right. Then that said, what we have here is STR.
Dimensions will be a number of columns and rows.
Yeah, which is this. So your answer is correct, but there's a problem with this because this is only useful to a human being that can sit down and decode this content, right? It will be difficult for you to supply this one to a program. So assuming you want to just read in the program, you want your code to read how many rows and how many columns, and use it to take a decision in another part of your program. That's why we have functions that we just give it to you like that. And the function we have is dim. Yes, dim will give us things like just in this simple form, and you can actually use this in programming. All right, you can say if the rows are more than this, then do that. If they're less than this, you cannot do that. You get. Okay, now. Yes, go on.
Sorry, sir.
Yes.
It means that there are
18,207 rows and 89 columns.
That's what I'm trying.
Now, if you are, as you are confused now, as me, I wasn't here. What you do is just you type question mark DIM, and then you tell you what this means. So, like I said, the help file is, if you are programming, you keep on referring to help. It's part of the process. Okay. Now let's look at the data types of the columns of FIFA. What is the fourth column and what is this data type? From what you know now, how would you treat this problem? I think still your STR now. You've already done STR. I think you can count it. I mean, with your current knowledge.
This is a long process now.
Yeah, yes. But you need to know to do it. Otherwise, you need to know other things, right? You need to know. So the question is, what is the fourth column and what is its data type? So the fourth column is which one? 1, 2, 3, 4, H. And its data type is integer. Okay? Alright, so next one is view the first few records of the data set.
The last few.
The first few. It says the first few. Then the last few. So the function to do that is head. Didn't head appear before? Oh. Must have messed with the slides. So this head function will give us the first few records. Actually, by default, it's the first 6. While tail will give us the last few. By default, the last 6. Okay? This is tail. Alright? Because yes, 18,207 is the last number here. Okay? Then, how many records were you able to see in each of the above instances? Is 6 now. I've already told you. If you wanted to view up the 10 records, what would you have to do? As me, I don't know. I mean, the function I'm using is head and tail. And they give me 6. What if I wanted to view 10 instead of 6? What should I do now?
Head, 10 FIFA or FIFA 10.
Okay, show me. should do what? Head. Head. FIFA. Dot 10. Dot 10. Are you guessing?
I'm guessing.
Okay.
But
Object FIFA.10 not found. What I've done now is I've created a new name entirely. But remember some names can have dots.
Okay.
and so that means
Okay,
it
so
should be
FIFA 10, space 10.
FIFA space 10. Let's try it. You're still guessing.
no, but
Unexpected numeric constant in FIFA.10. So this 10 is unexpected.
FIFA is the object itself.
Yes, it's the object.
So if FIFA is the object itself, my inquiry should be before the object.
Why guess?
I'm only thinking that.
No, you don't think in this case.
So head 10 FIFA.
No? I don't know.
Because what?
Now that I don't know, what should I do?
Yeah.
Help. Simple. There's no, never try to guess, so you're just wasting your time.
Help head.
Because functions are created deliberately. And the author of the function has given it certain guidelines and rules. If you break it, the thing will not work. And there's no, like in R, like I discovered the hard way. There's nothing like it should be this or it should be that. There's no intuition per se. You get me? Like I showed you two functions. One uses a name, and the other one uses a string of that name. So how do you explain that? You just have to go and check in the help file. So what you do is just check the help file, help of head, and quickly it opens it for you in your browser. It's a local file. You see this local thing. It's a local file. See head returns the first and last parts of vector matrix table data frame blah 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 blah. Head X usage. Default S3 method. I'll teach you about S3 methods later. You see head X N equals 6L. And I told you that by default it's now of course I agree this is already a bit advanced for you a little bit, but it's not too far-fetched. By the next 1 or 2 classes you will know what this L here stands for and all that, okay? But the bottom line is for you to understand that the help file is where you have to go to. And if you read the help file, as me, I'm a newbie now. I was like, what are they saying in this help file? Because the help file can actually be confusing to a new to a newbie. So what you do, let's go to Google. Go to Google straight. Don't even waste time. Let's go to Google. And there you say check first few rows. Something like that, first few rows in R. Or something like that. You will likely find something. See, select the first 4 rows of the data frame in R. Make it able to show 10 large values of a variable. How to select number of rows from the data frame, right? So it may be something like this, or this view data. Yeah, see, we have it here now. And from here, can you see it? So click R.
Okay, so head FIFA N is equals to 10.
Yes. You saw it then now in the listen.
FIFA N is head FIFA N is equals to 10.
So you see there's the example is here anyway. She saw it already. I'm not seeing it here, but it's there in that. See, print the first 10 rows of my data. Head, my data, comma, N equals to 10. Okay. Okay, so now let's now do it in this. So just say head, FIFA, and reverse 10. Okay? And then when you run it, it gives you the first 10 instead of the first 6. Okay? That's just the. So what you've learned here is really how to get out of your jam, because there'll be many of them. Okay, this is the last slide. Thank you very much. Do you have questions? We have 10 minutes left. Do you have questions?
My question, which is more like a concern for me, is now that I download the file, the zip file, it goes to download. What am I supposed to do that I will recognize it for me to report it?
Okay. You didn't want to move it from with your regular listen.
So,
You didn't want to move it with the regular
Copy and paste.
copy and paste. You want to use it to do it in R.
yes.
Okay. Well, the way to do it in R.
Okay, maybe you could explain if I'm doing the regular GUI operation and if I want to.
Yeah, like now, like what I did was I saved it directly into the folder where I wanted to work with it.
Oh,
So you can equally go to open your file explorer and move that file to the folder where you want to work with it.
is it
Either-
compulsory that it must be on
either-
our directory?
No, it's not in our directory. It's your working directory.
Okay.
For all you care, you can make that download to your working directory.
Okay.
But it's not wise. It's always good when you are working in a project, create a directory for that particular project and work inside it. Because why? Because when you're working in R, in that directory, there's some invisible files that R creates, like the history, those certain things. So that when you maybe close that particular job you're doing, or you leave it, or you exit R, some data about your session is kept. So you need to have. It's always good to create a unique directory for every project you're working on. So all you need to do is create a directory. But if you want to do it in R, you can copy the write in R. There's a function called file.copy. So you get the path to where it is, and then supply the new path you want to use. You want to send it to from and to, and to copy the file. Then you can now delete the other one. Okay. Any other question? Okay. Thank you very much.
When I'm working on my own, then I'll start asking what I will say.
Pardon?
When I'm working on my own, I'll send you my own questions.
No, notice that the reason why I created that Slack channel.
You said we can ask questions?
Yes.
Okay.
Because the good thing about that channel is that, or about Slack itself, is that you can actually format your code properly so that it's legible. So if it's a question that needs to be expressed in code, you can do that then easily. And also, I also intend to throw in things there from time to time. I might just wake up and give you an exercise.
I think this slides there too.
Yes, I want you to send the slide. I want to send the slide.
Today's class.
Yes. Do you want the video as well?
Yes.
You don't need video. What did the slides? We already have a video of this, although the glasses are quite different anyway.
Now, I will put the video first.
Not one. I'll give you all slides, video, everything.
Sir, let me be on my way, please. I'm trying to